Okay, so example 2 says if a 100-degree arc of a circle has a length of 9 inches to the nearest inch, what is the radius of the circle? So we're after the radius, right? What's the 100? That's my angle. It's theta.
Oh, okay.
So 100 degrees. What is the 9 inches?
Arc length.
Yeah, it's the arc length of 9 inches. Okay, they just put arc of a circle has a length, but it's arc length of 9 inches. So that's your S. Now we know, but theta's going to have to be in. So we're going to multiply by pi over 180. Which reduces to? Alright, 10 pi over 18, which reduces to? It did reduce to that, but you should know all the way. Yes, 5 pi over 9. Good. Alright, so we know S is equal to R times our theta in radians. S is 9. We're looking for R, and our theta is 5 pi over 9?
Yes.
How am I going to solve for R?
Move the 5 pi over 9, dividing it.
Okay, I can. That gets a little messy because it's a fraction within a fraction, right? So I'm just...
Put that... Why did you put it in degrees then?
Because the rule is with the... When you're doing arc length, the formula says it has to be in radians.
Can you multiply 9?
Yeah, I'm going to just do it a piece at a time, though. I'm going to multiply by 9 just to get rid of the fraction first. And so 81 equals R times 5 pi, and then divide by the 5 pi. Either way, I won't say one way is shorter than the other because by the time you do keep it, change it, flip it with the other, this way is probably about the same amount. All right, so we know if we wanted exact that our radius then is equal to 81 over 5 pi.
Yeah.
And what would its units be?
Inches.
Inch. But it told me to round to the nearest inch.
51.
So R is approximately, what?
51.
All right. So be really careful when you put this in the calculator because 5 pi is in the bottom together, isn't it? In the denominator. So make sure you put that 5 pi in parentheses, otherwise it will give you the wrong answer. So let's try that again.
5.1.
Yeah, it comes out to be like 5.16 or something.
5.156.
5.
All right, but it says round to the nearest inch, so the whole number, which would be 5 inches. So I'm not going to box that top one because that would be our exact answer, but this one was specific and said round to the nearest inch. All right, so there's example 2. Okay, example 3 says find the angle in radians and convert to the nearest degree. Well, we're after our angle. So when I come over here to the side, though, what is this 5?
That's your S.
That's my radius. And what is the 8?
Is your arc length.
Yeah, that's that arc length, so that's my S. So we know R is 5 and S is 8. So we can use our formula again for arc length. So S is equal to R times theta. So 8 is equal to 5 times theta. So divide by 5, and we get theta is equal to
1.6.
8 over 5 or 1.6 radians, right?
Do you want us to put a decimal or just leave it like that?
Either one would be okay since it's exact. Normally we don't have to label radians, but I went ahead and did label this time so we don't forget that that's what it is. So if we're looking back at our notes. And then it says to convert that to degrees. So how do I convert that to degrees?
Pi over 180.
Now I want to go to degrees, so degrees goes on top. So 180 over pi.
I'm confused. Why do you not have a pi in
Yeah,
your...
because there's no pi on there, right?
Okay, you don't have to have pi in your answer for radians, okay? Radians can also be just a number without pi in it. All right, so go ahead and just put your 8/5 times 180 over pi in your calculator because it tells me to convert it to the nearest degree. So we're going to round in the end anyways. So what do we get here approximately? Yeah, I got like 91.67. You're right.
The picture doesn't look, that would be 92.
You're right. It's not drawn to scale, is it? So they're being tricky, huh? So we know that theta then is approximately 92 degrees when we round it to the nearest degree.